All right. Welcome, everybody. Welcome to Open Source Friday. I'm Bruno Borges. I'm a developer advocate at GitHub, Microsoft. And today we're going to talk about a project on from the Java ecosystem that it has been developed in collaboration with AI agents, but not solely. And we're going to talk about what the project does. We're going to talk about how this developer that I'm going to welcome on stage built it, the principles used, and then learn how other developers and other maintainers, open source maintainers, can use the techniques shared in today's video. So let's welcome on stage Gunnar. Hello.
Hey there. Hello, Bruno. Thanks so much for having me. Super excited.
Yeah, my pleasure. Thank you for being here with us. Just for folks to understand, like you are in Germany right now.
Yes, that's right. So 7 a.m. Friday evening, best time of the day to hop on a live stream with you and talk
Lovely.
about this project.
Awesome. I'm from Montreal. I live in Montreal, and it's amazing to have this connection because you're in Germany, I'm in Montreal, and I'm sure we have viewers from all around the world
Right.
in on this on today's session of Open Source Friday. So,
Absolutely.
Gunnar, tell us a little bit about yourself and what are you working on these days?
Right. So I work, as you mentioned, I work as a software engineer and technologist at Confluent. So that's the company which originally created Apache Kafka. And so in this role, it's quite multifaceted. So I spent a large time of my share just to understand where the market in the data streaming space is heading. So what are like new technologies? How does AI, for instance, play into all that? I try to stay on top of all those projects like Kafka, Apache Flink, Debezium change data capture, which I used to work on for a long time. And for instance, then to understand, so is this relevant for our company? How is it relevant? So all this kind of stuff, like let's say understanding the market and competitive analysis, that's part of it. But then also I spent a fair share of time like writing on my blog, going out on conferences. Thought leadership in the widest sense, I guess. And then I'm also like, of course, working hands-on. So I do open source projects like the one which we are going to talk about today. I'm helping the company with prototypes for new project ideas. So all those kinds of things.
All right. So your blog, I think it's morling.dev.
Right. My last name .dev.
Is,
Yeah, I write a lot about Java, so I'm part of the Java community for a long time. Maybe people have heard about the 1 billion row challenge, which was a coding challenge, which I did like 2 years ago. So yeah, also try to do fun stuff like that. But generally, like working on with Java, then in the data space, in the data streaming space, that's sort of my sweet spot.
So for folks who don't know, there was a challenge a couple of years ago called the 1 billion record challenge, which was how to process a file or a bunch of files, not just single
file.
Well,
one file with 1 billion rows. That was the idea. Yes,
1 billion rows in a single file. I'm pulling here the link to that project on your GitHub. There you go. So it's github.com/Gunnar Morling/1BRC. What was the deal with that project? Like, why did you come up with that project?
Yeah, people keep asking that. It was kind of random, to be honest. It was like 2 years ago, between Christmas and New Year's Eve, I had some free time over the holidays, and I was tinkering around a bit with stuff, and then I felt, okay, yeah, let's see whether we can do this kind of coding challenge, and let's just see how far we can take Java to process that 1 billion rows, which, by the way, is like 13 gigabytes or so of data. And then it kind of went viral. People from the Java community, but also beyond, joined. Still, the repo is actually every now and then I still get like notifications. People still open issues or try to contribute. I mean, it's kind of like has been finished for 2 years now, but still people are talking about it. And and also people ask, will there be like another challenge? And maybe at some point.
What about 2 billion records?
Yeah, that you could, or like people, let's have like a 1 trillion row challenge or whatever. But no, I think it would have to be something different. But it would have to be like as easily to explain, like everybody understands that problem. But then also it needs to provide all the potential to tinker for like a couple of weeks with it, right? And so that's the challenge, to find another problem like that.
So I take like one of the challenges of like reading large files, um, and I'm gonna ask you a bunch of stupid questions. Um,
Sure.
so please do feel free to call me stupid.
Oh no.
But the idea is to learn, right?
Absolutely.
And to me, when I think about a challenge like reading a large file, is one, if I know the data that I want, how can I access that data directly? Two,
Right.
if the file is not structured in a way that I can access the data directly, how can I load that file in memory and then scan the data? But if the file is
Absolutely.
too big, what are the strategies that I have to use to find the data that I'm looking for? Was that
Absolutely.
some of the things that that challenge helped
Absolutely,
people understand?
100%. Totally. I mean, it's a lot, or that challenge. It was a lot about parallelizing the problem. I mean, so just to give some context, so the file had like 1 billion rows, and it had like random temperature measurements keyed by like weather station IDs, and the task was to find the minimum, the maximum, and the average temperature value per weather station. So you had to scan all those 1 billion records, and then to parse those records and to essentially aggregate them, right, and like find min, max, and average. And so, yes, it's a lot about parallelizing that problem. I mean, it lends itself very well to being processed with multiple cores, right? So yes, you want to probably load it into like native memory to work, not on the heap, and you want to deal as much as possible with primitive data types, all those kind of things. Yes.
So and do you think my recollection of that challenge was that the file was a CSV file?
Yes, it was a semicolon separated file,
Okay,
actually. Yes.
sort of CSV. Okay, not
Exactly. Right.
standardized CSV.
Yeah. And I mean, that was the thing, it all was a little bit random. So, I mean, just to, because I didn't really expect that many people to participate. So, for instance, what I had done is the output which I showed, it was just like what Java's hashmap toString function would happen to give. And
Right.
so that was kind of like the output contract. And people then tried to solve the challenge with all kinds of technologies, also, for instance, like relational databases. And then they would go to great length to emulate that Java hashmap toString output with like a Postgres or whatever database, right? And it was just, yeah, I don't know. I was kind of caught by surprise that many people would participate. And had I known, of course, I would have, be much more prescriptive about the constraints. But so we had to kind of build that plane as we were flying.
Was the SQL database implementation the most curious one, or was there another one that you felt like, okay, never thought somebody would solve this problem this way?
Oh yeah, I mean, that was like COBOL, like, of course, like all the databases like Snowflake, all kinds of languages. Of course, Java. It was meant for the Java community, but then also people did it in like all kinds of languages you could imagine. Tools like people would do it like in Awk on the CLI. So every possible tool you could imagine for solving that problem, people did use it.
Have you tried since then? Because it's been a while. It's been a couple of years, right? Since
Right.
that
Yeah.
challenge
Two
went
years a
live.
bit. Yeah.
Have you thought about throwing coding agents to solve the problem and see what they come up with?
Right. Yeah, it would be interesting. I mean, back then, actually, there was one entry by Antonio Goncalves. He's a colleague of yours, right?
Yep.
So he back then, I don't know what he used. Was it Copilot or I'm not sure. I mean, it was like pretty early for those coding agents, right? And back then, he came up with something which solved the problem, but it was kind of slow. I mean, to give people an idea, like the top implementation, it would run on my machine, like with all the CPU cores. So this was a big machine, 32 cores. This would crank through that data set in 300 milliseconds. So it's like, it was like insanely fast, but also like super bespoke optimized. And I think that implementation which he did took a couple of minutes. So, definitely not up there. But also now, of course, like quite some time has passed, and it would be interesting. I would imagine, well, I mean, all the agents have been trained on that repo, right? So
yeah, I wonder if they would like just pick the fastest implementation and have a variation
yeah.
of it,
Exactly.
So we have, when we talk about data sets, we talk about, I mean, there's structured data on relational databases. We have non-structured data on
Right.
non-SQL databases or data lakes and whatever. But when at some point the data is inside a file, right? And there are different file formats for hosting data, and some file formats are text-based, plain text, like God forbid
Right.
YAML, but XML and JSON and TOML
What
and
have you? Yes.
whatever, right? CSV, for
Yeah.
example, right? when it comes to binary format for storing data, what are some of the options today?
Right. So I think as so often it depends on the specific use case and what exactly you want to do with the data. This determines how you would want to store it. Now, as you mentioned, CSV, I mean, that's a row-based format, right? I mean, everybody has seen it. Like one record of your data, is it like customers or like temperature measurements or whatever it is? It's like one line in that file. And now if you want to get that entire data set, well, you can, iterate through it. And if you want to have like one entire record, well, if you know it's a line, it's like it's offset in that file, you just can go there and get that entire record. So that is kind of useful if you want to access entire data records, right? And probably would add something like an index so you can do it efficiently, so you know where to go in that file. So, and typically that's what you would consider as an operational workload. So like, this is kind of like how databases work. Well, they don't use CSV files, obviously, but, they work with that row-based data representation. Now, there's another world where you want to do large-scale analytics queries on like troves of data. So you don't want to access like a single customer record or a single purchase order, but instead you're interested in processing that entire data set. You want to know what's the average order value per customer category per month. For this kind of query, well, you need to look at large volumes of your data, right? And then you aggregate it and you sum it up, you take the average, you find the maximum, you do maybe window queries, whatever it is, right? Now, for doing this sort of analytical query, storing that data in that row-based format, it's not good because, well, let's say you want to, just for the sake of the example, you want to find the maximum temperature value in that data set. Well, what would you have to do? You would have to go through all those rows. Then you would have to find where is the specific column I'm interested in. So you would have to navigate to that. Then you would have to go to the next row, and so on, right? And would be pretty inefficient. So now, this is where those what's called columnar file formats come into the picture, because they essentially pivot the data. So they store the data, well, in a columnar way. So this means like all the values of a specific column, they are stored consecutively. So all our temperature values, they would be stored like one after the other. And then all the values from the next column, they would be stored one after the other. And now if I want to go and find out like my maximum temperature, well, I can iterate very quickly through that chunk of temperature values just by scanning that specific file. So it's very caching friendly. I can do things like vectorized operations on that data, and this is typically how you would store data for like those analytical use cases.
So for folks to kind of visualize, and correct me if I'm wrong, so when you have a traditional row-based file format or data structure, it's like an Excel spreadsheet, right?
Yeah.
But what you're doing is kind of turning the table
exactly right
to the side, like a 90-degree turn,
right?
And then now you have, okay, row 1 has the column A
exactly right.
and all the values
exactly
for
right.
all the records, right?
Right, exactly right. And this, so that's exactly right. And now this opens up a few interesting, opportunities. So for instance, let's say you do what's called a projection. So you are just interested in that single column. Well, you just have to read that part of the file, right? As you say, that it wouldn't be a row, but that's a consecutive section of a file. So you just have to read that. Or if you want to process it, well, you can go through it just by reading that file, and also or reading that section of the file. And also, it's actually tends to be very efficient to be stored depending on the kind of data. So let's say your values would be like ordered timestamps. Maybe it's measurements, and each measurement has a timestamp, and this data is ordered. Well, what you could do now is you could say, instead of storing like each of those full timestamps, you just store the very first one, and then you just store like the delta to the next one. So maybe that's like just 2 milliseconds after the first one. So you just have to store a 2 instead of the full thing, right? And so you would do what's called like delta encoding, which is that very, very space efficient. You can compress the data very well. So that's all those reasons why you would store data if you have this kind of use case.
And you can do that with anything, right? Not just timestamp. You can do that with financial values, with
Right,
numbers.
absolutely. And exactly. And there's all kinds of encoding. So for instance, there's what's called the dictionary encoding. So let's say you do have strings, but it's like a known set. So maybe it's like 100 different city names. So instead of like spelling out those names, you could create like a dictionary. So you'd say, okay, Montreal, that's 1, Hamburg, that's 2, and so on. And then in your file, you would just store, well, the dictionary at some place, right? And then in the actual column values would just store those IDs. And then if you parse the file, you would go to the dictionary, and then you would be able to resolve those values.
So does it? So it kind of it is compressed by design, right? Like the file.
It's very compression friendly. Yes, exactly. Because if you have let's say just those like numbers one after each other, this could be very efficiently compressible.
So what options do developers have today if they come to a point where, hey, I need a columnar file format and I need to transpose my data from my database to this file so I can have analytical process on it? What are the options today?
Right. And great question. I would say most of the times people, would maybe even do that already, maybe not even knowingly, because if you are using what's called the data lake, so something like Apache Iceberg, this is exactly doing that. So, those kinds of what's called open table formats, they manage those columnar files. And now there's different options, but Apache Parquet, that's the most prominent one. Has been around for quite a while, and that's definitely the de facto file standard for those columnar files.
So Parquet, Apache Parquet, so this one here.
Right, exactly right.
That put on the website. So this is just a file. The Apache Parquet is a project that defines the file format.
Right. So they define the file format. They define. There's like a very well-written specification. There's a implementation, of course. So there's a parquet-java parser project and writer project, and then also very importantly, there's a canonical suite of test files. So they have like a couple of hundred parquet files which show all the different encodings, different compression algorithms, all the different features, different data types, and so on. And now if you want to implement like a new implementation of that format, having that specification and then also having those test files, that's super valuable.
Yeah, I'm looking at the documentation here, and interesting.
Right. So they give you in using Thrift, they give you like the definition of all the different blocks of the file. So there's what's called column chunks, which are organized in row groups, and using those schema definitions, you have a very precise understanding of how that is structured.
What is the magic number used for?
It's just there to tell you, that this is a Parquet file. So a little bit like every Java class file, it starts with like Cafe Babe, right? So that's the same thing here.
Okay, gotcha. Cool. So when it comes to implementation, there are a few options here. I see.
Right.
So
one is missing.
There is. Yeah. Let's talk about that. So I mean, clearly, there's a bunch of implementations. I mean, I see 3 implementations in C++. One of
right.
I don't know what is CUDF C++. I don't know. Do you
know? No, I'm not sure.
I have no idea. But I see 2 in Rust.
Right. Of course.
1 in Go and 1 in JavaScript.
I'm sure there's others in other languages. It's widespread.
But do you wanna talk about why you came up with a new implementation?
Right. So yes, as we see here, so there is an implementation in Java, right, which is widely used, and people use it successfully. But I think there's 2, or let's say there were 2 reasons for me to build a new implementation. And we should say that. So that's what we are talking about, right? Like a new project Hardwood is a new implementation of a Parquet parser in Java.
So let me plot here on the screen. So project Hardwood, this one here. Okay,
right.
Cool.
Exactly right. So so the idea is like Parquet, Hardwood, different kinds of flooring. So that's where the name is coming from. And so why a new implementation? Well, A couple of reasons. So first of all, the existing one it has been around for quite some time, and in particular, it has quite some heavy dependency baggage. So essentially, you just want to parse a Parquet file, but you pull in the entire Hadoop stack of dependencies. So that's like dozens of jars. It's like your class path is
it's not like fully standalone.
Exactly.
Like parsing library.
And, which made sense because it came from that context, and this is how the project came to be. But so that's a huge problem, right? So you have this huge dependency footprint, and, it opens all kinds of questions around, having different versions of your jars on your class path. How are all those transitive dependencies? Are they secure and up to date? And are they conflicting with each other? So it's kind of like a hassle, I would say. So that's a dependency situation. And then also it's single threaded, and this problem lends itself very well towards being parallelized, as we have learned during the 1 billion road challenge. And so I thought, okay, it would be nice to build a new parser, and hopefully in the future also a writer for Apache Parquet, which is which has minimal dependencies. So that's the one thing, like one of the leading paradigms. So there's no mandatory dependencies. There's some optional dependencies. We can talk about those later on, but no mandatory dependencies. So if you pull in this Hardwood core jar into your project, it has no mandatory transitive dependencies. So that's the one. And then, it's fully multi-threaded. So it tries to take advantage of your, CPU, of all the CPU cores you have. So that's the idea. So, I felt, okay, there's just a need for building a new parser with those ideas in mind. And then also, I just wanted to also, I saw it as a nice opportunity to, put those agentic coding tools to work and see how good are they for building such a relatively low level thing, right? So I'm not building like a CRUD UI React web application here. It's relatively low level. And I was curious, okay, how can I do this with those coding agents?
And in here, I think, I'm going to open here your blog, because I think you wrote, when you announced the project back in February, there was something really cool. I love this section here. I mean, there is, for folks who want to understand, like, go deeper in what Gunnar just said about why the project, his blog post on morling.dev covers in details. And there is the parsing performance, and you just mentioned, right, like the 1 billion record challenge helped come up with some design principles for this new implementation. And I think that's fascinating. When I wonder what other stories we have from people who solved the advent of code and then came up with new ideas for new libraries,
it's kind of funny because back then, actually, people also asked, hey, why are you doing this challenge? And so there was different ideas, like, let's say, conspiracy theories. So people said, oh, because GraalVM and native binaries, they did really well in the challenge. So they said, this is like a hidden advertisement for GraalVM, which it was not. And also some people said, okay, I just had this problem at my workspace and I couldn't figure it out how to solve it myself. So I kind of farmed it out to the community, which also wasn't the case. I just thought it's a fun challenge. But now, actually, I'm taking some of those learnings and I'm applying them to building this production-worthy Parquet implementation.
Well, I forgot to ask you this in the beginning, because you said, it was like at the end of the year and you decided to do the 1 billion record challenge.
Right.
Was that because you got bored because you finished the advent of code?
You always have some low time between the years, as we say in German, right? And so I just clip into that. And this year, actually, or let's say last Christmas, this was when Hardwood was born.
Awesome. So back to your blog. So there is a performance, and I mean, for folks from outside the Java ecosystem, the JVM, the hotspot JVM, the runtime of the Java ecosystem has amazing capabilities for analyzing performance, right? And I think a lot of folks from outside the ecosystem, and even some folks inside the ecosystems, don't know the capabilities. So can you talk a little bit about what we're looking at here and a little bit
Right.
of the tool set that you used for performance analysis of the library?
Absolutely. I mean, so what we see here, it's a tool which is called a JDK Flight Recorder. So this has been around in Java for quite some time, but initially, it wasn't like open source, and there were some licensing questions around. But since a couple of versions, it's open source, and you can use it at your liberty. And essentially, it's exactly that. It's a recorder for all kinds of events, which again are stored in a very efficient file format, actually. And so the idea is to have a place to store all kinds of diagnostic information about garbage collection, about class loading, about method profiling, about locking, about IO, all kinds of metrics, and they keep adding more and more event types in each Java version. So they are stored in this flight recorder file format, and here we see this tool, Mission Control. Actually, that's the client for analyzing and examining those recordings. And so yes, you can use those tools to get like really deep insight into the performance characteristics of your Java application. So I don't know, you have, let's say, high tail latency. So you would be able to understand, okay, this is related, I don't know, to garbage collection at certain points in time. And why are we creating that many objects? You can see what are your allocation hotspots and what can we do about it. There's tons of built-in metrics. But here, as I'm a big fan actually of those tools, there's also the ability to have custom flight recorder events. And so that's what I'm also using in the Hardwood project. So there's, event types which will be emitted. I don't know, if we have finished a row group, or if we have like our consumer is blocking, it's waiting for IO. So, we would emit such an event. And then you can use Mission Control to gain those performance insights. So that's a big one. And then async profiler. That's, I would say, the standard profiler in Java for identifying like what are your bottlenecks in terms of CPU time, wall clock time, again also memory allocation, and so on.
So we have two tools here that can be used by not just Java developers, but any JVM-based language developer that uses the hotspot JVM. So that is Java, Scala, Kotlin, Clojure, even Ruby. Like if somebody's using JRuby, right? The Ruby implementation for the JVM, they can use these tools for performance analysis of their applications, their libraries, and so on. It's really cool. Absolutely. So I'm putting here, I put here in the stream the link to dev.java. It's a website where developers can learn about Java, and there's this page for JFR, or the JDK Flight Recorder, so you can learn more. And the other tool,
that's great. I mean, as you say, it's still a bit underutilized. Not too many people know about it. So definitely, Flight Recorder is great. And yes, async profiler. That's the profiler which but also like most people in the Java community use heavily.
You know what's fun? I was a month ago, almost 2 months ago, I decided to use AI agents to build an SVG to PNG converter tool or library in Java. And after having some design ideas on the API, I told the agent, hey, use the Cairo SVG, which is a Python library, API design to expose the same approach on how the developer would interact with the library, with the API. But the internal implementation is completely different because it relies on Java 2D graphics API. But then eventually I was like, hey, agent, now let's do performance testing, right? And I said, go do some flame graphs, go do some analysis of where the bottleneck is. And the agent decided by itself to use the async profiler. I was not explicit about async profiler. The agent found out, I can use the async profiler for that.
Right. So and it's actually also, it can analyze those flame graphs. So it's all coming together.
So for folks who want to learn more about async profiler that has flame graphs, here's the URL, github.com/async profiler.
Right.
Cool. So back to your blog. So the performance analysis helped a lot with, making sure you tackle every bottleneck. And after you tackle a bottleneck, you go to the next one and the next one and the next one.
Right.
And making sure the design is clean at the same time, so you can add capabilities in the future. But the section that I love more is this one here: build with AI, not by AI. Can you tell us about this?
Right. Absolutely. So as I mentioned, the one idea here also was, yes, let me use this project as some sort of a real world testing bed to see how far can we get with the modern agentic coding tools. And I would say, they are doing like a really good job. So the vast majority of the code in this project is implemented. I'm using Claude Code, I should say. So, that's the vast majority of the code is built by Claude. But I'm not vibe coding, and I just also think it's not a good idea, generally speaking. So yes, I used those tools a lot to generate code, but then I also I want to make sure I understand it and I understand the structure, and I'm actually very deliberate and explicit about like APIs, what is public, what is internal to our code base. How is the general architecture? So I work kind of with a relatively prescriptive design process. So actually, also you can see that in the repo we have those design documents. So typically that would be like the first phase to let's see, a certain feature. I don't know, new kind of let's say want to add support for Bloom filters. We would first have the coding agent do like a design for that, and then we would iterate on it. We would try to nail down corner cases and so on. Think about testing. Think about what's the user-facing API of that, and then we would have it actually implemented. So yes, and that's exactly right. Why it's called with AI. So heavily using this also for reviewing contributions and so on. But it's not AI in the driver's seat. I would see it as one of the tools we are using.
Right. So I feel like this is the sort of like reason why I like to advocate for AI agents to be part of the flow, not be an isolated flow. Like
Right.
I like when I did the SVG library, I was interacting heavily with it.
Right.
But at some point I felt like some tasks I could delegate and then just review the after.
Right. Absolutely. I mean, sometimes it's also just not very good what it gives to you, right? And so you got to guide it then into a different direction. And I mean, we have all seen that, right? Oh, when it tells you, oh yeah, that's a great idea, and you're so right. So sometimes it can also become like a bit annoying.
You're absolutely right.
You're absolutely right. And so why did you not think about it then in the first place? But yeah, so I think I mean, in no place I would have made that much progress as I did in that short period of time without using those tools. But also there's limits. And I mean, in terms of like understanding the code, so as I mentioned, I think it's very important to be really on top. But the way I think about it is like I know. I mean, there are certain pockets in the code which I don't fully understand to the last line of the code. Let's say I haven't looked at them, because I mean, let's say there's 1 out of 5 different encodings, and they can be tested very well. They are very well defined in the specification, and so for that, I'm fine with knowing, okay, there's this implementation. It passes all those test files which the Parquet community provides, and then I'm good. So I'm not looking super closely at those parts of the because I also know, I mean, it's the abstraction principle, right? So it's like
right
behind an interface, you don't need to care that much how it's looking there. But what I'm really keen is to, like the overall architecture, like the I/O flow. How do we parallelize? What is public API? What is not public? I'm really on top of those things because, I mean, they are harder to change, right? And I think that's with everything, you want to pay the most attention to those things which are hard to change or costly to change.
It's almost like you want to make sure that, in the same way that we interact with LLMs without exactly understanding the implementation details of the LLM, I mean, libraries are similar to that. For the end user who's using the library, they don't care about the implementation details to some degree. As long as it's well documented, they understand, oh, this method is thread safe, it's not thread safe, things like that. But the outside, the public API, as you said, that is the part that you want to have strict control. But once you have that, and once you have that, it allows you to make changes internally using AI or not, without affecting
Exactly.
the
Yes.
end user.
Yes, absolutely. And that's also why I think it's just, I don't know, I feel like those end-to-end tests, they work just like really well for this kind of problem, or for this kind of implementation approach, let's say, because, in the end, I have a set of test files, which I even get from the Parquet community, so they provide them. I can compare what the Hardwood parsing result is. I can compare that to what the upstream Parquet-Java parser emits. And if there's a difference, well, then obviously, I mean, yeah, probably there's a
Right.
bug in our implementation, right? And so, yeah, I can iterate on those things very easily, right? So initially, we didn't support, or we didn't pass all those test files, and this was like a sweet spot for the AI tools. I could say, okay, there's this one test file, we don't support it yet, we don't pass it yet. The test is failing, or we have like a different result than the upstream parser. Please go and make it work, and this works perfectly for with those tools.
I used a similar approach when I needed more task cases for SVG to PNG. I just said AI,
Right.
hey, go build like 50 SVG use cases that cover all the capabilities of the SVG 1.1 format, so that I could have unit tests for every single capability that was implemented, but then also a mix of them, like how do different features of the SVG format can work together, and if the library would render properly.
Absolutely, yes.
So would you mind to show us your library, talk about it over showing the code, and maybe run some examples, just so people can have a feeling of like what the code looks like? And
right, yeah,
also
absolutely. I mean,
I'm also interested in you showing your flow, how you interact with AI coding agents. You mentioned that you use Claude, and that's totally fine, and we are happy to show Claude here in the Open Source Friday. It's what is really interesting, and I think what people will actually enjoy, is seeing how you, as a maintainer of a library, is using AI coding agents, whether that's Claude, Gemini, Codex, or GitHub Copilot. It doesn't really matter.
Right.
What matters is how can other maintainers learn from your experience using AI coding agents for an open source project?
Yeah, I mean, I should say I feel like I'm still like super early on my own journey, and I'm not sure how much people can learn from me. I feel like I'm learning, not so much every day myself. But yes, of course, I'm happy to share. We can take a look. So you want to bring my screen online?
Yeah, sorry about that. There you go.
Right. Okay. So here we have the Hardwood repo on GitHub. By the way, you totally should give it a star. We should have many more stars. That would be awesome. So yeah, that's the code here. Let's see. We have this website, which gives you the like how you get started, what's the Maven coordinates and so on. So that's hardwood.dev. And so yeah, let's start with the API. So it's I would say relatively straightforward. So there's this what's called a Parquet file reader. By the way, is this big enough? Should we make it bigger? Oh, is it good? A little bit. All right. So there's what's called a Parquet file reader. You can point it to a Parquet file, and then you can retrieve the values in two flavors. So there's what we call like the row reader API, and this now essentially gives you a row-based representation. So we go through all the records, which are stored in a columnar way in the file, but here we access them as records, right? So I have this API where it iterates through the records in the file, and we will get all the values from those column chunks. And we can just, give me a long for the ID field, give me a string for the name field, and so on. So that's the most basic way. And there is also what's called the columnar API, because here, this actually, I mean, as you see, it kind of goes against the grain of dealing with columnar data, right? So let's say you want to aggregate all the values of the, balance column. Doing this sort of thing, it seems not pretty efficient, right? So this is why there's also what we call the columnar API. So there's a column reader, and now this column reader, this actually gives us the values from a specific column, and there's also there's a multi-column reader and things like that. But here in this case, let's say I have this fair amount column. So this is, maybe people even know this. This is like this NYC taxi ride data set. So that's a pretty popular data set of Parquet files, which you can get from the New York Transit Authority with all the taxi rides in New York City. So let's say we are interested in those fair amount values, and now here we actually get batches, essentially arrays of values from that column. And Now here you can, if you can process those very efficiently, right? Because it's like arrays of consecutive values. You could think about like threading this out to multiple processors of columns. But yeah, so we have those two flavors: row-based and column-based. And now this is how you generally deal with that. Now there's many more things you can do. So there is things like, for instance, filtering. So let's say I am interested only in specific subsets of the data. I don't know, maybe here I have like, this kind of HR data, and I'm only interested in those parts or those records where the salary is greater than 50,000. And here we do what's called a predicate pushdown, because very commonly those files actually are not local on my own local disk, but they are stored on object storage. Let's say S3, and I don't know what's the counterpart in Azure. Bruno, you need to help me out. But there's also some object storage. Right?
Well, we have Azure storage. That would be the
Azure storage, right? So those files would be stored there. And now, if I think about it, you don't want to download, if you can avoid it, you don't want to download the entire file, right? So instead, you would only try to get those parts of the file which have those records you're interested in. And Parquet supports that, for instance, with statistics. So there's a way where it tells you, okay, in this chunk of that column, from this offset to that offset, you would only find records with salaries between 70 and 80, for the sake of the example, right? So now if I run this sort of query, then okay, if I'm just interested in anything which, let's say, is below 50, well, then I don't even have to fetch that entire chunk of the file, right? So that's what's called predicate pushdown. We only get those sections of the file which are matching those filters. So we have that. Of course, I can do what's called projections. So I only get specific columns. I don't need to get the entire thing. So yeah, there's all that. Let's see what else is there. There's this S3 API. I mentioned that already. So I can, instead of getting files locally, I can get them from like remote object storage. And now this is actually also an interesting thing which I realized while I was working on that, because if I'm using this object storage, very often I would use the S3 SDK for doing that, right? So there's from the AWS API, they give you an SDK for accessing object storage, which works great. But again, it's pretty dependency heavy. So if you look at that SDK, it's do I want to pull in this dependency in everything it pulls in it by itself? So what I did here is instead I implemented pretty much everything from scratch. So because in the end of the day, this is just like HTTP requests, right? So this is a REST API, so we can use the built-in HTTP client in Java to fetch those files. And now, in the case of S3, those requests, they need to be signed. And there's a bespoke signing algorithm which AWS documents. How do you have to sign those requests? And now, back in the day, this would not have been something which I would have considered to implement myself, because I feel I can mess it up. I don't want to maintain this code. I would just get this dependency. But now here, I think the consideration is actually very different, because, well, they define that signing algorithm, again, very well, and they give you like a test suite of all kinds of edge cases for how the signing has to look like. So sending off a coding agent to implement this works very well. And so I have my own custom request signer. It passes the test suite, so I know this is guaranteed to work with S3, and I don't have to pull an external dependency. So this entire, a make versus, well, not buy, because I mean, I'm not buying those dependencies, right? But let's call it make versus buy. This consideration, it gets moved dramatically with those tools. You can take ownership actually of code parts and functionality which you would not have done typically in the past.
Now you mentioned something interesting here, which is you ask the coding agent to go and implement an S3 client component right within your library, basically, right? But because you have such a very specific use case, it didn't have to implement all the capabilities that the S3 SDK has. Now,
exactly.
Now, there is a question though of, if the S3 SDK was not open source, how would it have been the result of the coding agent? And I tend to believe that it would not be that bad either, because I mean, S3 does have a REST API. It does have
the API is there, right? So right? I think it would work well. And I mean, the thing is, you need to be cautious, where you draw the line, because there's actually one small dependency which we have here, and this is related to how you authenticate, because if you have
Right.
used S3, you will know there's like a gazillion of different ways you could authenticate, right? So like with machine identities and IAM roles and like local access key and so on. Now I felt I didn't want to implement all those authentication mechanisms by myself. So this is
Right.
where I
Right.
pull in something. But yeah, you can. The needle shifts quite a bit.
Interesting. So we got a question here on the on the stream. Can we show the CLI?
Absolutely, yes. So for context, so this started as a library, and so you would use this in your JVM-based applications to parse Parquet files. But then I thought at some point, I had this idea, okay, that also could be a ready-made library, right? It's a little bit like curl and libcurl. So oftentimes you have like those CLI tools which expose functionalities of a given library, right? But I thought this is something which I want to tackle later on. So right now I'm really focusing on the parsing aspect. That's what I want to nail down for 1.0. But then it's open source, and people, if they are interested, they work on the stuff they are interested in and what they need. So actually, a contributor, Brandon Brown, he came and he said, "Okay, I want to work on that CLI, and I want to work on it right now." And so that's why we have that CLI. And so I have a little demo here. And so here the idea is, should make this bigger. The idea is, it's like a Swiss Army knife of for dealing with Parquet files. So I don't want to re-implement DuckDB or like a full-fledged database client, but it's a Swiss Army knife for dealing with Parquet files. For instance, to show me the schema. So this is something which I can do, or to get some metadata. I can see, okay, this is what the kind of data is here in this file. This is like a couple of rows from the file. I can take a look at those dictionaries which we mentioned, and like the encodings and so on. Can convert data. So that's the idea. Swiss Army knife for Parquet files. And now the interesting thing is, to me, interesting anyways. So also this API is written in Java, and it's very snappy. And back in the past, people oftentimes felt, yeah, Java is not great for CLI tools because it's like too slow to start up and this kind of thing. And now, actually, this is a native binary which we distribute for Windows, Mac, and Linux, built with GraalVM. And so now this is a self-contained native image which starts up super fast, and so you also can use Java to build those CLIs. So this is what it does, and if people want to play with the CLI, you can get it from the releases page. So everything is on GitHub, and we have, like as I mentioned, like those ready-made CLI binaries for all different platforms, and also like Intel and ARM.
Okay, we got another question here also. How does this compare to Polars? I don't know what Polars is. Do you know?
That's I should know. I'm not 100% sure either what Polars is, to be honest. Is it not like a data frame format or something? So I feel before I say something stupid, I know. Can I ask Claude about it? Let's see what he says.
Yeah.
Let's do that. How does Hardwood compare to Polars? I have no idea. I'm curious. Let's see.
So for folks tuning in on the stream, we are talking about the project Hardwood, which is an implementation of a Java-based implementation of a library to parse and read Parquet files.
Right. 100% exactly right. So yes, it says a very different category: Hardwood Java library for CLI for parsing Parquet files, minimal dependencies, all the things we spoke, and pullers, a Rust. Oh, I see. So this is for the Apache Arrow memory. Yes. Okay. So yes, Apache Arrow. That's an in-memory format. So it's not a persistent file format, but it's an in-memory format. Also dealing with columnar data. So there's like a relationship between storing columnar data in files in Parquet and then reading them into Apache Arrow in-memory vectors. So yeah, I mean, people see it here, right? So it's different tools for different use cases, I would say. I mean, there's some overlap, right? As I see it here. So if you want to analyze data, filter, aggregate, join. So yeah, with Hardwood, it would give you at least some filtering capabilities, but for instance, not joining. So I suppose Polars is on like another level, let's say.
So now you explained the tools, you explained the library, the API, and you explained the CLI.
Right.
Can you walk us through a little bit, like if you go to the GitHub issues right now on the Hardwood project, and you decide, I'm going to tackle this issue here. What is
Right.
what does your flow look like?
I mean, as a contributor, or myself?
As a maintainer of the project.
All right.
Like, okay,
Yeah.
this issue here is bugging me as well. It was
Right.
filed by another person, or maybe
Right.
by you a few weeks ago, and you're
Right.
like, okay, I got tired. I already solved all the advent of code. I already did the 2 billion record challenge again, and I have nothing else to do. I'm going to fix another issue on Hardwood.
Right. Yeah. I mean, to be honest, I would point my coding agent to it and say, I mean, then it depends a little bit on the complexity. So, either this warrants like a design document, and I want to say, okay, give me like a design document. By the way, we have those all also in the repo, so people can see those. Somewhere, don't find them. There you go. So I would ask it to create something like that. So, if it's like a complex thing, like, okay, let's talk about predicate pushdown. I mean, we have that by now, but let's say we want that, right? And so I would ask it to create something like that, and then we would iterate. We would talk about it. Oh, I feel like, something's missing here, and so on. And at some point, I would feel, okay, this is ready to be implemented. So that could happen. Or if it's like a bespoke bug fix. So for instance, earlier today, there actually was an issue. Somebody asked, so, hey, this, inequality filters and how they work with null, that's not sufficiently documented. So this is something I can just point, Claude or whatever tool to it and say, okay, yes, please make the doc updates to do that, and or maybe explain that issue first of all. Maybe I'm a bit dense, right. I don't understand. So yes, walk me through the issue first. So that's what I would typically do. Yes.
Do you? So I love the idea of the designs folder, because I mean, at the end of the day, that's what spec-driven development is about, right? Like you exactly. First come up with a specification, whether you use AI or not, it's irrelevant. The point is, you have a specification first, well thought out, ideally reviewed by a human, ideally reviewed even before a human by other agents using maybe different models. Right. But the idea is, here's my concept. You have a challenge, I have a problem, I need to solve it. Here's a way to solve it.
Absolutely.
One thing that that maintainers can consider is, you mentioned about like evaluating the effort of fixing a bug or implementing a feature. There is something really cool on GitHub now called GitHub Agentic Workflows, and this capability allows developers and especially maintainers to create agentic workflow like GitHub Actions, but agentic, so it triggers a coding agent, and you can do things like, if an issue is filled or a new issue is created, triggers the workflow automatically to do an analysis of that issue and provide maybe an effort analysis, or identify duplicates, or identify scope or context, or maybe adding relevant data that is missing from the issue, or maybe reformat the issue submitted by the developer. And I've seen a few projects now using it, especially, of course, at Microsoft and GitHub, but they're using these GitHub agentic workflows for that purpose.
Right. Yeah, absolutely. I mean, it's the sky's the limit. So I actually have it hooked up with the GitHub CLI. So, well, no, not authenticated, but usually, if I were authenticated, then this would be able to interact with my issue tracker. It would I would ask it, hey, can you quickly log a follow-up issue for that particular kernel case? I would ask it to grab issues from the tracker and so on. So I also do that a lot. And actually, I would like to get to a state. I mean, right now all this happens here in my terminal, right? And I would like to get to a state where I actually can have also this planning phase on the designs actually through GitHub issues. So I would like to have like a conversation there, and it would maybe come up with a draft in the GitHub issue or wherever, and then I would read it, and I would then maybe reply by email. Okay, this sounds great, but can you also think of that phase or whatever? And that would be great.
That's something you can do right now. I mean, you can go and create an issue and propose an idea, and then assign to Copilot with an additional prompt, hey, come up with like 2 different proposals for this problem. And then you have a pull request created associated to that issue with the plans. And you can instruct to drop those plan files in your _designs folder.
Absolutely, yeah.
Yeah.
I know, but
So,
for me, it's always I very important to have like this human in the loop step. So I
oh yeah,
I want
100%.
to review the stuff, and I want to be, because in the end of the day, this is also, if when people send a PR and it's crap, you cannot say AI did it, right? So you have the ownership. So in the moment when
Yeah.
you propose something, you do it. You have to own it. And if you propose crap because AI told you so, this is totally on you.
Yeah.
So you have to be on top of it.
I think we when I did one contribution to the project recently, and I went
Right.
through a few iterations over it. So it's a pull request that has lots of commits, not a single commit. Like, oh, here's a problem, go solve it. Like, there's a bunch of back and forth, and that, I think that's a sign. So developers who used to like squash merge and put a pull request on a single commit, I actually kind of feel the other way around now. Like, I think pull requests should have as many commits as are required, and as part of the flow of developing and iterating, and showing that
Absolutely,
the
yes.
developer cares about what they're proposing.
Totally, and you can rework them. By the way, those are all your all the things you did, and there's one pending. So yeah, and in the end, you can squash them, right? So I mean, you don't need that temporary
when
history.
you merge the pull
when you're done,
request, you can
exactly.
squash it. But I think sending a pull request with a single commit, I think that can show the developer did not care, just used AI to generate the whole thing,
Like
and
one
that's
off.
it.
Yeah, totally.
Right,
Absolutely.
a single shot. Cool. All right, we are at the end of the stream. So how can folks reach out to you, Gunnar, if they have questions about Hardwood, Confluent, Kafka, Parquet,
Right.
and
Yeah, I mean, they can. I'm on all kinds of places. Let me see. People can find me on my blog, on my website. I'm on can find me on Twitter. Can find me on LinkedIn. So yeah, you can reach out to me on all those channels if you want to contribute to the project. I mean, by now, like dozen or so of people have contributed. I mean, you're very welcome to do so. Go to hardwood.dev. That's the starting point. Give it a GitHub star if you haven't done so. That would be amazing. And yeah, I don't know. I'm super excited about all that.
And you're also on Twitter, Blue Sky, whatever, all the social networks, I guess.
Right. Yes. I mean, I'm not sure. Is Blue Sky still a thing? It seems like it's. I don't know. But I'm there, and I'm on LinkedIn. I'm on Twitter, and obviously on GitHub. And you can send me an email. Everything is great.
Awesome. All right, Gunnar, thank you so much for this. This was a great session. Appreciate you sharing the project and the work that you have been doing. For the next Open Source Friday, we're gonna have Teja from Kong, who will explain API gateway, AI connectivity, and also have another project called Open Meter. Have you heard about Open Meter?
Not sure. No, I don't think so.
Okay, well,
I've heard about Kong. Yeah.
Maybe you should tune in on Open Source Friday next week.
Yeah, that's a good point. Awesome, bro. This was fun. Thank you so much for having me.
This was great, man.
This was really great.
Thank you so much. And for everybody watching, thank you so much for following, and see you next Friday.
Bye-bye.